Hello, everybody. My name is Ebo. I'm in my second year of my PhD research. I'm investigating the interdependence between sugar futures contracts, which are popularly known as futures markets. But on this presentation, I'm going to deliver on the stationarity properties of the sugar price series, which is the preliminary analysis for any macroeconomic research using time series or price series data. Second slide, David. Okay, like I say, I'm a PhD doctoral researcher in the School of Business and Entrepreneurship at RIU. I've in the past worked in various roles within the car rental industry before turning to postgraduate education. Apart from my commercial experience, I've also held different positions as a visiting lecturer, including the current one at RIU. And my research interests lie in two distinct areas: the efficiency and interdependence of agricultural commodity markets and price transmission dynamics among agricultural commodities and their influence on market structure and practice. Next slide, David. So when we talk about market interdependence, there are so many descriptions and so many constructs of market interdependence. Market interdependence focuses on disturbances or shocks across market linkages that could be volatility spillover or the core movement of prices. Market interdependence also represents the influences of one market on other markets interaction or the interaction among them. So the basics of my research is constructing the interdependence construct or framework that will be presented in my research on the as a theoretical framework which I can derive my hypothesis to be tested. However, the construct I'm working on is on the long run and short run dynamics and error correction mechanism, the causality between the markets, that would be the market power, and volatility spillover. In essence, the whole research is focusing on market price relationship and behavior. Next slide, please. So the sugar markets. The sugar markets, they're also viewed as the contracts markets. We got futures contracts or we got the spot price markets. But my research is focusing on future markets. The future contract is a standardized legal agreement to buy or sell any agricultural commodity at a predetermined time. It is time in future between parties not known to each other. So there are three main international sugar futures contracts or markets. So the first one will be contract number 16. That will be for USA grown raw sugar. This serves as the hedging needs for US sugar producers, users, and merchants. And the contract prices are physical delivery of only US grown raw sugar. And there is contract number 11 that represents world raw sugar. It is the world benchmark contract for raw cane sugar trading. And the contract price is the physical delivery of raw sugar produced anywhere in the world apart from the United States. And we got the contract number 5 that represents world refined sugar. That will be the white sugar. That will be also the global benchmark for the pricing or physical delivery of refined or white sugar. So in contract number 5, it doesn't specify or it doesn't distinguish between cane sugar or beet sugar. So beet sugar and cane sugar, they're all represented in contract number 5. Next slide, David. So my research data, I'm using secondary data based on the price of the sugar for all three contracts. And in this case, this price series are my price variables, and it's quarterly from 1990 quarter one up to 2019 quarter four last year. So my variables are US raw for raw sugar, for US raw sugar, world raw, and world refined as shown on the slides. And the data I am collected from the Department of Agriculture, the USDA Economic Research Services, which collects and publishes all the data concerning sweeteners trading worldwide. So the data, it is accurate data. So even though it's open access, anybody can look at it. It is updated regularly and it's accurate benchmark for the future sugar prices. Let's see. Okay, like I said earlier, this presentation is just on the preliminary analysis which I've just concluded, and it's based on the unit retesting or determining the statistical properties of my X series or my variables. And when we talk about a unit root, unit roots are statistical properties of the price series. In my case, that is the properties of the mean, variance, and autocorrelation that are not consistent over time. They tend to drift away. And the importance of unit retesting is mainly really to avoid spurious regression or obtaining a high R2 values, even if the data is uncorrelated, and to avoid errant behavior due to assumptions for the analysis not being valid, especially when the T ratio, the test ratios, will not following the T distribution. In essence, this can all be grouped into one meaning to avoid inaccurate results. Pretty much that's all. That's why the unit roots as testing is so important in any research analyzing microeconomic data. And in this presentation, we'll be discussing the two main tests, the augmented Dickey-Fuller test and the Phillips-Perron test. Although they do the same thing, they're different in essence. The ADF test can handle bigger and more complex models. It does have also the downside of a very high type 1 error rate. Whereas the Phillips-Perron test is a modification of the initial Dickey-Fuller test, and it corrects the autocorrelation and the heterodisticity in the errors. That's the main advantage of the Phillips-Perron test. So I chose to use both tests because of their limitations and advantage over each other. So having similar results will prove my analysis on the unit regressions to be correct and achievable, accurate. Next slide, please. Okay, this is the descriptive statistics of all the three variables. That's on the y-axis, it is the average prices, and on the x-axis is the quotas from 1990 quarter one to 2019 quarter four, representing 120 observations. So that's how the trend, all the three is evolved over the time. And looking on this visual representation, I can already see there are some unit root tests, not tests, unit roots within the data. It's not trending, but it is just moving, drifting away. And also, I can see there are some spikes which may significantly affect the type of analysis I'm going to use, especially on the initial unit test. And also, it will account for structural shocks within the data. This could have been intermediate shocks due to policy changes, volatility, credit crunch, and it could be anything that will have an impact on those spikes. Next slide. Okay, I've used the EViews software, EViews version 10, the full student version, to do these tests. The first result you see on your screens. I've got two outputs, one for the ADF test in levels and one on the ADF test on first difference. So looking for the test in levels, the null hypothesis is US raw, world raw, and world refined has a unit rate. So I use the equation containing both constant and a linear trend, and the result the test only used one lag, and out of 12 lags are chosen automatically, but it only used one lag. So our key emphasis here is on the ADF test statistic and the test statistic with the critical value of 5%. So the rule of thumb when employing the augmented decay follow-up test, the T statistic on the critical value of 5%, as you can see on the screen, is larger than the ADF T statistics, which indicates that all the price series, they do have a unit root. Their mean variance, they are not stable over time. So even if you look on the P values, they are more than 5%. And then we look on the levels, or before we look at the ADF test first difference, in order to make my variables stationary, not containing root tests, I difference in the first difference. Everything stays the same, but the difference is on the results. If we look now on the T statistic of the critical values of 5% and the ADF T statistic, the ADF T statistic are more negative than the T statistic critical values of 5%, which indicates that my data has become stationary after differencing it once, and the P values are less than 1%, which confirms the stationarity of the variables. So my variables after first difference, they are stationary of order 1. Next slide. Okay, now on the Phillips-Perroni test, I did the same. I did the same. I ran it first in levels and then in first difference. So in levels, I did as well equation containing constant and a linear trend, and the equation only used one lag out of the maximum lag of 12 chosen. So now the difference between the two is now the PP test, it corrects the errors in the ADF test, but it still have the same implementation of the regression process. So if we look on the PPT statistics, they are less negative than the T statistics of the T statistic critical value of 5%, and the P value is more than 5%. Again, in levels, the PP test has shown that the data is not stationary. And then the same thing, I did the same thing in first difference. And now if you look on the PP test, statistics and the T statistic of critical values, the PP test statistics has become more negative than the T statistic of critical value of 5%, and the P value is less than 1%, which also confirms the data, my sugar price series, they are all stationary after the first difference. Next, please. So what does these results tell me? The results from both the ADF and the PP test have shown that all the variables of the price series are non-stationary in levels, and they became stationary after the first difference. Therefore, it is confirmed that all the price series are integrated of the same order, that is integrated of order 1, which is represented by I1 in brackets. And now this, like I said earlier, looking at the descriptive statistics chart, there are some spike. And as we know, I'm using microeconomic data, especially the prices. I don't expect the prices to be the same from Q1 1990 until last year, Q4. They are, it has shown some spikes, some structural breaks. So these tests I've done so far, they only confirmed, yes, after the first difference, they are stationary. But these tests, they were not accounting for structural breaks. So now I'm going back to do the same test using different methodology, accounting for structural breaks. So these breaks may confirm the stationarity of the ADF test or the PP test, but if they don't confirm that, I will continue the analysis using structural breaks in my analysis, especially using the Carrion-i test. It accounts for at least 2 structural breaks in a price series. I think that's the way forward on this, because the descriptive chart have shown some spikes. So there are some way, some structural breaks. We don't know what they are. Maybe sugar policies, world sugar policies, American protectionist of their sugar industry. It could be anything, even political climate or even the climate. It could, but definitely I can see there are some spikes, some structural breaks within the data. So now I am continuing running the same unit root test, but now using methods accounting for structural breaks within the time series. Thank you.